All right, welcome back, guys. We're going to do percent composition by mass, this worksheet. There are notes on Drive that you should probably take. It's maybe a table of 2 columns and 4 rows, so it's not really anything bad. It's maybe 4 questions that you're asked to do. But before we even get into this, I'm going to flip it, and I'm going to give you an example of how I would do this, or how you could do this in real life. So percent composition by mass, all it is basically figuring out the mass percent of something. Like if you have a bag of if you have a bag of cereal and the total bag weighs 100 grams, right? And you know that you have 75 grams of cornflakes, corn F, and you have 25 grams of chocolate chips, choc chips. And what this is asking you is what's the mass percent of, let's say, the chocolate chips? How would you figure that out? Well, simple. The formula or the equation would be mass of element over total mass, molar mass. And you're probably thinking, what the heck does element have to do with a bag of cereal? Well, the total molar mass is basically the mass of the molecule. So in one bag of cereal, we know that it weighs 100 grams, right? And we know that we were trying to figure out the mass of an element, so the mass of what it's asking you for. So if you want to figure out the total mass percent of chocolate chips, you would do 25 grams, because that's the total mass of chocolate chips, over 100 grams. So, and then you would multiply it by 100. Doing this, you would end up getting 25%. So chocolate chips have a 25% by mass composition. Likewise, if it was asking you what's the percent composition of cornflakes, you do the exact same thing. I have 75 grams over 100, and it would be 75%. Now let's flip the page and let's get to some nitty-gritty good stuff. Okay, so a chemist determines that 1.6 grams of iron reacts with 0.54 grams of oxygen to form rust. What is the percent composition of each element in the new compound? So what we have to do is we have to find out our total molar mass, right? The total mass is going to be 126 plus 54. So that's going to give us, I think, 180, right? When we add that together. So it's going to be 180 is the total mass. And we're trying to find out the percent composition for each element. So in order to find out oxygen, oxygen has a mass of 0.54. Yep, 0.54. And this would actually be 1.8. I'm sorry, guys. So 0.54 times 100%. And that would give you the percent of oxygen. Now, if you want to find the percent of iron, it's the same thing. 1.26 over 1.80 grams, and then times 100, and that would give you the percent. So these are pretty straightforward. It really starts to get more complicated once you get down. So once you start to get to number 4, my favorite, bam. A compound contains 1.2 moles of carbon and 3.2 moles of hydrogen. What is the percent composition by mass of each element? So, because it's asking mass, you can't do moles, right? Moles is not good. You need mass. So in order to get mass, you have to do your favorite thing, which is dimensional analysis. If I want to figure out the mass of 1.2 moles of carbon and the mass of 3.2 moles of hydrogen, what I do is I have to figure out the masses first. So if I have 1.2 moles of carbon, I'm really abbreviating here. So we start with what you have, and I'm trying to get to grams because that's mass. I know that 1 mole of carbon is equal to 12 grams. So I would multiply that out and it would give me something like 14, I think 14.4? Yes, 14.4 grams. So 14.4 grams over 1. I'm sorry, 14.4 grams of carbon. And then, if I want to figure out the mass of 3.2 moles of hydrogen, I have 3.2 moles of H for 1. I know that I want to get 2 grams, so dimension analysis. I know that 1 mole of H is equal to how many grams? 1.0 grams. So do this across and you have a mass of 3.2 grams of hydrogen. Now, you're not even done. You're halfway there. Now what you have to do is you have to figure out the mass composition of this, right? So now what you do is you figure out the total mass, which is 14.4 plus 3.2, and then you're going to have to do this same thing all over again to